Let's talk about reversing powers. Now, I don't mean handling a vehicle when traveling in a backwards direction. What I mean is that we have in the past talked about things like x squared, meaning we're taking some x unknown number of things and turning it into a square. So x may in this case be 5, and therefore 5 squared is 25. We also abstracted that off to 3 dimensions and said, well, we could here be talking about making a cube out of this thing, and therefore we'd be talking about x cubed, and then how many things would be in this cube? Well, 5 times 5 times 5 is, what is that? 25 times 5, 125. So if you had a cube that had 5 things on each side, you'd have 125 in total. So let's take another slightly harder example. Let's imagine, and excuse the fact I'm not going to draw all of these, but imagine that we have 4,096 little cubes making up a bigger cube. Now this could be, for example, a physics-based voxel game. Voxel is this word here. And this is where instead of using pixels, you use 3-dimensional pixels called voxels, a bit like Minecraft. And we want to know, how big is this thing? How big is it on one side? What is x here? And that is the unknown. And we're starting here to do algebra, the unknown. So what are we asking? We are asking the question that x times x, now notice the difference between my x's and my timeses, equals 4096. Now one valid way to solve this puzzle as to what x is to just guess at it. So you could say 10 times 10 times 10, if I can write properly, and that would equal 1,000, so that's not enough. So then you would try maybe 20 times 20 times 20, and that's 400 times 20, which is 8,000, so that's too much, we're bust. So we know the answer's in here somewhere, it's between 10 and 20. Now you could just keep guessing, and actually this a method of successive guesses where you improve your guess each time. It's called numerical solving, and actually can be sometimes the only way to solve a question like this. But in this case, we can do better. We can do something called an analytical solution, or we can just go straight to the right answer if we know enough math or maths, depending on which side of the pond you're on. So let's carry on. Let's write this in our compact notation we've already learned, which is that x cubed equals 4096. All right, just shorthand for x times x times x. We've done that before. Now, I'm going to show you a mathematical rule. I'm going to tell you it in the abstract first. A to the power of b all to the power of c equals a to the power of b times c. So I'm just going to put a box around that for you for a moment, because, in fact, let's do an actual box rather than a random, slightly dodgy shaped thing. Red box. All right, so what this is saying to us is if we have some number raised to the power of some other number, and then you raise all of that to the power of c, some other number, then the way that these two powers interact is that you multiply them. Why? Well, we don't really need to get into that. We just need to know that this is the rule for the manipulation of these symbols. In fact, either satisfyingly or disappointingly, depending on how you look at it, the whole of maths really is just a system for manipulating symbols, okay? But it does give some very powerful results. So we're going to understand what this means a little bit better by doing it. So if that's the rule, then we can see that in this instance, our x is our a, and 3 is our b. So we could do something useful. What we want to do is we want to get back to just x, don't we? This is our goal. We want to know that x equals and some number. So we need to take a few steps to get there. Well, in mathematics, this is where mathematics gets creative. To turn x to the 3 into x, how about if we raised it to the power of a third? Don't worry about what raising it to the power of a third means just yet, because the whole point of this exercise is to teach you what raising it to the power of something to the power of a third means. But if we were to do that, look, by this rule that we've just talked about, 3 times a third becomes what we're seeing here, okay? So this is the same as saying x to the power of 3 times a third, all up the top there, but what you do to one side of an equation, a bit like a balance, an old-fashioned weighing scale, you know, you had these things, weights hanging off the end and maybe a balance point. You have to do the same thing to both sides. So we can't just raise this side of the equation, this thing here, to the power of a third without raising all of this to the power of a third. So the thing that's very, very important is that we do this, is that if we raise this bit to a third, what was on the left-hand side, we need to raise this bit to a third, i.e. what was on the right-hand side. Okay, given that rule about equations, that you always do the same thing on both sides of them, let's crack on. So x to the power of a third times 3, or 3 times a third equals 4096 to the third. Now, this is x to the power of 1 equals 4096 to the third. So now hopefully we can see why I chose a third here. It's because when we multiply 3 times a third, we get 1. 3/3 are a whole. One way of looking at it is like this. Here's a third. 3 of those make a whole. Right? So with that said, that is why I decided to multiply 3 by a third, so that we would get back to 1, which is back to the x, which is the very thing we were looking for. And we've actually kind of got our answer. But how do we work out what 4096 to the third is? Well, we can do that. On a calculator, you would go in and you'd go 4096, and then you'd say to the power of maybe open brackets 1 divided by 3. It's also approximately equal, and that's the sign, if you wanted to do it on a more basic calculator, to the power of 0.333, you know, and then we can keep going. We can keep doing those 3s. Okay, so it's approximately that. And the answer, of course, is 16, because 16 times 16 times 16 is 4096. Exactly as we expected, it's a part of the way between, not exactly halfway, but about halfway between 10 and 20. All right, so we've got that. Now, there's a couple of other ways of writing this. You may have seen a square root. So the 4096 to the third is written in mathematics like this. The cube root, so the square root of 16 equals 4. This is how you write that, because 4 times 4 equals 16. And with a square root, you don't have to write this little 2 here. You can if you want, but it's implied most of the time, so you don't write it. But in a cube root and above, you can do any root. You need to write the 3. Awesome. So let's just stand back from what we've done. We've given ourselves a way of undoing powers, of reversing powers. So I said not handling a car in reverse, but taking something that we have done, like raising 16 to the power of 3 and getting 4096, i.e. this cube has 16 on all of its sides, we now know. We've taken that and we've reversed it. We've said we know the 4096, and we know we multiplied it by itself 3 times, but what is this 16 thing? So, cool result. Hope you're pleased with that, and it will be very useful to you moving forward. Quick Game Dev TV green smiley face, and I will see you soon.